This is the BBC Microbit microcontroller we've been using to program everything. This is the physical interface. This part here is the battery for connecting a battery if you want to use it without the USB terminal. This is the USB terminal which is currently connected to the computer. This is the processor reset button. That's the BLE antenna in the top left corner. This is the Nordic processor. We've also got internally a compass, an accelerometer, and a few other features. At the back we have 25 LEDs in a 5x5 format and 2 programmable buttons. The pinout, it's easier to look at this drawing. We have some ground terminals, and there is possible to use SDA, to use I2C to communicate with a bus protocol, and to use SPI. We can also digitally program some digital pins, I/O pins, and we've got some analog ins that we can make use of, as well as triggering some LEDs. The I2C protocol is a protocol intended to allow multiple slave digital integrated chips to communicate with one or more master chips over short distances. In this example, the BBC microchip will be used to send and receive a signal from the processor to the accelerometer, and we're going to view it over the logic analyzer. So we wrote code to send a read request to the X most significant bit value, which is 0, 1, into the device, and read back what 10 bits thing. We can see on the logic analyzer that we sent the address of the device with a read and then an ACK. Data write is the address of the register in the device for the X parameter. Address read is the I2C, the port or address number, and then this is a 10-bit. Well, we read 2 bytes back, and then we convert them into a 10-bit unsigned integer, which looks like that. And then when this is converted to 10 bits, we're left with something like this, which we can convert binary to decimal to get -8, which shows up on our GTK terminal. So this is just a quick video of me getting the SPI working on the flash memory. So I edited the code just to send a personalized message, and now I'm sending a read back, and this is it reading in the GTK term, and this is just the hex conversion. So that's the message received, that's the hex conversion, that's the matching message. So this is the video showing the entire project working together with the BLE scanner app. The microchip will be acting as a peripheral to communicate with the BLE scanner app, which is the central. The code we've written is, this part includes all the libraries that we'll be needing, including the 2 services which will be sending the data via Bluetooth. This is declaring some LEDs we're using for indication purposes. This is setting up our device name and declaring our services. These are service pointing to our services. This is our I2C thing we were using for looking at the I2C parameters. This is the address of the accelerometer and the magnetometer. This is enabling the serial UART. These are declaring the 2 main loops we're going to be using to update our accelerometer and magnetometer fields. This is setting up the gap for which we're going to be communicating with, or the peripheral is going to be advertising with, so the app can see it. The GAT this is sending stuff to the GAT, which is used for setting up our central or our characteristics and our services. The main loops of the app are update acceleration, which is using the I2C protocol to talk to the main processor in the BBC microbit to talk to the accelerometer. This is sending data both to I2C and to our Excel service, which is sending it to via BLE to whatever app is connected to it. This is similar to with the magnetic field, except it's talking to the magnetometer service. This is our main loop, which is basically calling this function every 1 second, which is reading all the values that we need. and this is both of this is waking the accelerometer and waking the magnetometer, and that's waiting for the event to happen. In the service, we're just declaring our character service, the UUIDs, and our the three XYZ characteristics, and we're sending them via Bluetooth, which we're getting these values from the main loop. This is connecting now to the thing which is called my app, which is called Dave. Searching and connecting, connect. That's found all three services. That's the LED service, this is the accelerometer service, and the magnetometer service. So I'll click into this service and look at the characteristics, and you can see that we read the values. So that's X, Y, and Z values, and then we can move the thing and we should get different values. So there's slightly different values now. This is our GTK term, which is updating the fields pretty much constantly. That's it.